Today, fingerprint authentication systems are used in a wide variety of applications to keep our information safe. However, these systems are still susceptible to attacks like biometric spoofs. For instance, it's still possible to use Play-Doh to obtain a user's fingerprint and use this to gain unauthorized access into a user's secure device. One approach to solving this is to check for signs of liveness. For example, we could check for the presence of a heartbeat in the user. Signals obtained via photoplethysmography, or PPG, allow us to do this. PPG signals are the same biosignals obtained from devices like smartwatches for estimating a user's heart rate. They're also used clinically in devices like pulse oximeters for estimating vital signs like oxygen saturation and heart rate. Thus, we introduced PulzeLock. PulzeLock is an early prototype of a device that is capable of estimating a user's heart rate, breathing rate, and oxygen saturation simply from a video recording of the user's finger. The user starts by plugging in the system. Once plugged in, they are able to select the vitals mode to estimate their vital signs. After recording for about 15 to 20 seconds, the system displays an estimate to the user. However, PulzeLock does not stop here. Our device differs from a standard pulse oximeter because apart from checking for vital signs, it uses the PPG signal as a unique identifier to either grant or deny people access into the secure system. The reason this works is due to the many differences that occur in the cardiovascular system from person to person around the world. For example, a difference in arterial stiffness could affect the nature of the PPG signal from one user to another. We exploit these differences and map them to specific features that represent one user given their PPG signal. For example, we illustrate with a user who utilizes PulzeLock as an authentication system. This genuine user takes a step away from their workspace. Now, unknown to the genuine user, an imposter tries to gain access into their personal device. When this imposter selects the ID mode, identification mode, they try to gain access. After a video recording, the system denies them and the imposter is not allowed in because their PPG signal does not match that of the genuine users. Thus, we present PulzeLock, an early proof of concept for vital signs extraction and user identification. In the future, we envision this system being used in secure places such as airports to prove that a user is truly whom they claim to be.